Hello gentlemen, I'll give a little introduction of our company Mark. We were basically founded in 2002. Our company was founded in 2002 to explore new technologies in IT sector and automation across all industries like steel, power, process industries. The basic purpose of a company is to make any process more efficient and to reduce costs by automating most of the process and bring cost cutting technologies to greater satisfaction of our customers. MacDill Incorporated has now taken over all the software business of Mark, and it is being promoted under the MacDill Incorporated brand. Our other businesses are still promoted under the brand name of Mark. Hello gentlemen, today we introduce to our Orifice assemblies. So I am going to begin this presentation slide after slide. I will be explaining you. So now just begin with the definition of the orifice. So orifice, you see, they are the most basic of the devices for measurement and control. The shape and manufacturing tolerances of plates used in measurement applications are defined in the international standardization publications of the ISO standard, the AGA standard, as well as the ASME standards and others. From the formulas and the data within these publications, the relationship and values of flow, differential pressure, plate bore are determined. In flow control applications, orifices are used as restrictive devices to regulate flow or reduce the falling pressure downstream of the orifice plate. The use of fixed restriction orifice can be beneficial and economic by reducing the demands on other flow system components. So you see, orifice is one of the cheapest means of measuring flow. Unlike measurement orifices, the sizing and design of restriction orifices are not defined by standardized organizations. Additionally, restriction orifices, abbreviated as RO, are often exposed to severe flow conditions associated with large pressure reductions and the related fluid conditions caused by liquids flashing to a gas, cavitation and sonic, a choked flow. In tortuous applications, mimicking the design of measurement orifices is not sufficient. The orifice plates are normally mounted between a set of orifice flanges and are installed in a straight run of smooth pipe to avoid disturbance of flow patterns from fittings and valves. In this diagram, as you are seeing gentlemen, the orifice assembly basically has got four parts. The first part is the orifice plate. Mostly we use thickness of 3 mm or 5 mm. The material is SS316 in orifice which we are using. The second part which you see, that is the bore or the orifice bore which is basically a hole in the plate which is calculated as per calculations. The third is the tappings which we are having, from which the flow or the differential pressure we will get. Now tappings can be either flange tappings or D/2 tapping. And the fourth plus is the orifice flange. The orifice flange depends, it can either be a weld neck flange or an SORF flange, and the flange material also changes. For acidic applications it is stainless steel, for other applications it is carbon steel. So mostly carbon steel is used for general applications. So you see, this is the basic diagram of the orifice. Presentation will be on segmental bore. Segmentally bored orifice plates are provided for measurement where solids are entrained in a gas or liquid flow stream. The circular portion of the bore is inscribed within a circle, which is normally 98% of the pipe diameter. The segmental opening may be placed either at the top or the bottom of the pipe. Industries which are using these are mostly sewage treatment, steel, chemical, water conditioning, paper and petrochemical. Segmental bore orifice plates are used for around 8 to 9% of all orifice plate applications. Discussing on this presentation, we will discuss on the various types of orifice plates. So what you are seeing right now, the diagram before me, it is the standard edge orifice or the square edge orifice. See, this is the most common type of orifice which we are using. It is also known as the concentric bore orifice. And in this, the bore and the level is the standard method of limiting the plate edge thickness. Unless otherwise specified, the plates will be beveled to the current accepted standards. So there is a 45 degree cut which we have to make on the side of the edge. that is the after the bore area, this in the direction of the flow. So this is one of the most common types of orifice plates which we are used. We mostly use this for water applications and normal applications. The metals that we are using in this case are nickel, monil or stainless steel. This orifice has the highest accuracy among all orifice plates. They are mostly used for clean fluids, clean gases and steam flow. So now we will go to our next presentation now. RTJ type orifice plates are used for some special applications. The RTJ type orifice plate incorporates an internal gasket which is between this orifice, either in oval or octagonal ring, for mounting between ring type joint flanges. It is based on proven technology and has no moving parts and is suitable for high temperature and pressure applications. Orifice plates are recommended for clean fluids, gases and low velocity steam flows. Plate thickness depends on line size and differential pressure and should be sufficient to prevent the plate from bending under operating conditions. Orifice plates can be made in accordance with customer drawings as required. RTJ type orifice plates can be supplied complete with ANSI B16.36 orifice flanges. So they are mostly used where, for steam applications there are chances where steam loss may be there or steam may escape. So these are the applications where RTJ type orifice plates are mostly used. Now the other type of orifice assembly which we are discussing is multi-tube type orifice assembly. Meter tube is a complete set consisting of a multi-hole orifice plate and straight lengths of piping on its inlet and outlet. Design of the meter tube is divided into three parts: inlet, in which the fluid flow is straightened, measuring part, orifice plate, and outlet. Straight lengths of piping in the meter tube comply with all conditions of dimensional and geometric accuracy as defined by ISO 5167 standard that are related to the pipe sections adjoining the orifice plate. This layout guarantee entrance of stabilized flow into primary element and accurate measurement of flow rate. Concept of meter tube also minimize non-conformities during assembly of orifice plates and their subsequent operation. So another type of orifice is multi-tube orifice plates, and they have got special applications where we are using multi-tube type orifice plates. In our continuation with the different type of orifice plates, today we are discussing on this slide is eccentric bore orifice plate. See, eccentric bore orifice plates are plates with an orifice off the center, that is below the center, or eccentric as opposite to concentric. In concentric orifice we had the hole in the center. In eccentric it is not in the center but a little bit below. The bore of the eccentric orifice normally is inscribed in a circle which is 98% of the pipe diameter, so that solids or slurries may pass through. As you see, solids and slurries, they are quite thick. So, if you are having a hole in between, it will cause clogging. Therefore, this eccentric bore orifice is used. Eccentric orifice plates are used in many industries like heavy and light, chemicals, steel, paper, nuclear and petrochemicals. So these are the area where eccentric bore orifice plate is used, and for thick and viscous liquids it is used. Hello friends, now I am discussing on the orifice type, that is the quadrant edge bore. The quadrant edge bore is a special type of orifice which we are using. The quadrant edge bore is an orifice with an inlet edge rounded. Instead of beveling, the plate is counterbored to the desired edge thickness. The radius of the quarter circle bore is a function of the orifice to pipe ratio, which we call D by D ratio. Thickness at the throat is equal to the radius. This bore is specially designed for viscous fluids such as heavy crudes, syrups, slurries with a Reynolds number below 1 lakh. So the major use of quadrant edge bore is for viscous liquids basically. In this slide of multiple type orifice plates, we were discussing like how important multiple tube orifice plates are, how much they help in orifice flow measurement. With the passage of the measured fluid through several tapped cross section reduces demand on minimal straight lengths of piping downstream and upstream the orifice plate necessary for proper functioning of this type of meter. Multi-hole orifice plate can be incorporated in both either vertical and horizontal piping. So if you have a horizontal piping or a vertical pipeline, both ways you can use multi-tube type orifice plates, and they do not require a very great length, because instead of one hole there are many holes, so it basically helps a lot. So this is the whole idea of having a multi-tube type orifice plates. In the last slide we will be speaking of multi-tube type orifice plates. We will be continuing that same presentation here. In this, the division of the meter tubes into individual sections also enable easier maintenance inspections or subsequent verification of the meter. There are corner differential tapping. These are incorporated in the body of the flanges, between which the plate is placed, centered and sealed. The pressure tapping is let out of these flanges upon agreement with the customer's outlet of differential pressure, as always customized to various options of primary element attachment to the metering circuit. Set of meter tube consists of stainless steel expander bolts that greatly facilitate dismantling and subsequent assembly of the disc. Use of multi-hole orifice plate is limited by beta is equal to d by d. The orifice plate is made for beta is equal to 0.4 up to 0.65. That is, for a beta ratio from 0.4 up to 0.65, we will be using multi-tube type orifice plates. Hello gentlemen, in a continuation of the earlier slide when we were discussing about multi-tube type orifice plates, so we will continue with our presentation. So in multi-tube orifice plates, if you see, for attachment to the pipeline, this section is finished with a preparation to the weld. For the production of meter tubes, there are mostly used a carbon steel, stainless steel or refractory alloyed steel. Disc of the multi-hole orifice plate is made of stainless steel as a standard. Upon agreement, the meter tube can be made of plastic materials too. Multi-hole orifice plate is manufactured either as a working meter or as a specified meter, with metrological verification complying with the technical particulars and conditions of the pattern approval. Except for advantages of centric orifice plates such as simplicity, replaceability and reliability, multiple orifice plates also have advantage of smaller installation length, enabling wider possibilities of their use. The other type of orifice plate that you are using is the multi-tube type orifice plates. In this, there are multiple tubes which are there in the orifice plate for flow measurement. Meter tube with multiple hole orifice plate is manufactured as well nominal diameters from 25 dn 25, that is around 1 inch, to 1000 dn. The meter tube with multiple bore orifice plate is manufactured with a straight line lengths of 2d. D is the diameter, 2d ratio upstream and the orifice plate, and 2d downstream. So 2d, like the upstream is 2d, in between the orifice plate is there, and the downstream is 2d. The section 2d downstream, the orifice plate is finished with a weld. Upon agreement with the customers, it can also be supplied with a flange, a counter flange, fasteners, as long with a flange and counter flange. Plus we have to give the fasteners and the sealing. The meter tube can be equipped with a section complementing entrance section upstream and with the orifice plate to complete the length of 4d or 8d, depending on the length of the fittings upstream of the orifice plate. So this is the basic type of multi-tube type orifice plates that we are using. Good morning gentlemen. On this slide I will basically show you the basic placement and the working of an orifice flow assembly. So diagram which you can see in front of me, just follow that and look for that tick mark. The tick mark is basically the process flow, that is the direction of the flow. The flow, it is flowing in which direction. So the first thing if you find is the DP transmitter. There is a differential pressure transmitter. This DP transmitter is mounted on a manifold valve. This manifold valve we are mostly using of SS316 or SS304, so that it doesn't get rusted in contact with water or any other liquid. Then we have a oval flange. Now the oval flange may or may not be required. You can use a straight flange also, a round flange. Nipple we are basically using for enabling to send the liquid from the orifice assembly to the transmitter. So his nipple is mostly made of SS316. And then we have this particular flange. They are companion flange. In companion flange, a hole is drilled inside the flange through which the flow you can measure. That is the incoming and the outgoing flow. That is the flow on both other sides of the orifice assembly you can measure. The mostly the flanges that we are using is either of SS316 quality or CS quality. Carbon steel again doesn't get rusted in contact with water, unlike mild steel. So we are either using carbon steel or we are using SS316. So then we will now continue further with our next slide. So I hope this placement of actual flow assembly is quite clear to you. You have basically understood how to install an orifice assembly and how the orifice assembly basically looks on installation. Good morning, gentlemen. In this slide we will be discussing the applications of orifice meter. In our all previous slides we were discussing like what orifice meter was, how many different types of orifice meter are there. So today our main concern will be applications of an orifice meter. What are the various applications that we are having on an orifice meter? So you see, the first is the orifice meter. It is used to measure the flow rate of fluids in their single state, that is gaseous state or a liquid state. So any fluid which is either in a gas or in a liquid state, orifice plate is basically used to measure that flow. It can also be used to measure the flow rate of liquids in a mixed state. That is an excellent example will be steam in either gaseous or liquid state. Like steam is an excellent example. It is both in gaseous state, and if it gets cooled down it can convert it into liquid state. So wet steam or natural gas in water, that can also be used. Fluid flow rates in a pipe can be measured. Any fluid flowing rate in a pipe can be measured by the use of an orifice plate. It is used in natural gas plants and water treatment plants. Petrochemical and refineries have a great usage of orifice plate and orifice assemblies. It is also used in oil filtration plants. So these are the basic uses and applications on orifice meter. Orifice meter is a very low cost device by which you can measure flow. So now we are just discussing on the various applications of orifice meter. So you can see a diagram just after me. That is an application where there is an isolation valve, there is a flow signal, a transmitter is there, and orifice plant is sandwiched in between. Hello gentlemen, on this presentation right now, on this diagram I will show you a GA diagram, which is a general arrangement drawing of an orifice flow assembly. So let us start. So first part, if you see in an orifice flow, is the flow direction. That is the direction of the flow. It is denoted by a mark. The process pipe is there, the flow is flowing from there. Then we have the D, the small d, which is the orifice bore diameter, which is the hole which we make inside the orifice assembly. Then we are using SORF flange here, and inside that flange we have carrier rings. So this orifice is basically an orifice with a carrier ring, and these carrier rings are either made of copper or of stainless steel, and they are sandwiched in between the SORF flange. So you can see here there are two flanges, there are two carrier rings, there is one orifice plate, and then we have an upstream flow tapping, then we are having another downstream flow tapping. In between these carrier rings we are using gasket for pressing the whole thing, and the whole assembly is then within the flange. The orifice plate, if you see, it has got a cut, a 45-degree cut in the direction of the flow for measuring the orifice flow rate. So the design that we are following in this is ISO 5167, and the other standard which we are following is BS standard BS 1042. The orifice plate will be made of stainless steel, and the carrier ring will either have a steel gasket or suitable gasket for that particular process. So gentlemen, just have a look there. I hope this GA drawing basically makes it clear for you to understand what is an orifice assembly and what is the general drawing of an orifice assembly. So let's move to the next slide, gentlemen. Let's move. Gentlemen, on this slide, as you see the topic of the slide, we'll be basically discussing advantages of orifice flow assembly. If you see orifice flow, we were discussing earlier in the slide, like what is an orifice plate, how many types of orifice assemblies are there. So orifice flow assembly has got many advantages. So we'll be tabulating these advantages one by one. Now the first advantage is it is cost effective and quite easy to use. So orifice flow, if you see, compared to Venturi or electromagnetic flow meter and many other means of measurement, orifice is quite cheap. And the second point is it occupies less space. You are like Venturi takes a huge space, around 2 meters, 3 meters. Orifice doesn't take so much space. Like orifice, you can either put it as a platform, or you can put it as the orifice plate with a carrier ring, flange, carrier rings between the flange, and you can put it in a. So either way, it doesn't take more than a space of 300 mm or 400 mm. Like you have to only cut the pipe up to 300 or 400 mm. If you compare that with a Venturi, so at least 3 meter of the pipe cutting you have to do. Okay, and orifice has got another advantage. It can be used to determine flow rates in large pipes. Large pipes above 500 mm, that is 1 meter, 2 meter, 3 meter, even DN 3000, 3 meter pipes. Orifice can be effectively be used to determine the flow rates in large pipes. See, another advantage which orifice has got is it can be installed in horizontal or vertical positions. So if you are having a pipeline in either in a horizontal way, or you are having a pipeline in a vertical position, it can easily be installed in either a horizontal or a vertical position. It is low cost and simple construction. See, orifice has got a very low cost, which I was discussing earlier, and the construction of orifice plate is also very simple. Easily installed and easy replacement. The installation of the orifice is very easy. You just required to cut the pipe in between, place two flanges, weld them, and then put an orifice plate in between. The maximum manpower which you require is a fitter, a welder, and a gas cutter, and maybe one labor, and the job is done. It hardly takes a day's time to fit an orifice assembly, or even not a day's time. Like it can be also be done in 2-3 hours. Compared to a Venturi, we have to take a big, huge shutdown. You have to have lots of safety hassles and that. There, see, orifice has got no moving parts, so regular maintenance is not required. Like compared to other flow meters like turbine flow meter or paddle wheel flow meter, which has got mechanical moving parts. So there, what happens, whenever any dust or any slurry or any foreign particle gets entangled within the flow meter, then there is lot of problems. You have to take the meter out, you have to clean it, you have to do a lot of maintenance. But in case of orifice, these maintenance are not required. There is an easy replacement of orifice. So if you find there is some faulty reading coming, you can replace the orifice easily. Or if you have a change in pipeline size, you can easily change the orifice. The same is not possible with other flow meters. And it is capable to measure gases or liquids with high accuracy. See, orifice is a very high accuracy device. Like the accuracy of an orifice is around 1 degree FSD. So to measure gases or fluids with a very high accuracy, orifice can easily be used. And it is available in many sizes. So an orifice is available for many sizes from 10 NB to 10,000 NB. Orifices are available and people are using them across various applications. So these are the basic advantages of orifice assembly. But definitely orifice assemblies also have some disadvantages, which I am going to discuss on the next slide. So then, gentlemen, let's move to the next slide. Hello gentlemen, this diagram you see, this is a flow diagram of the orifice flow assembly. So this is an integral block, and on top of that you see the manifold and the DP transmitter. So this is an integral orifice assembly where the both parts of that integral block along with the pipe and the combining flanges are all welded together. So you just need to fix the transmitter on top of that. This is a new type of orifice assembly. It is mostly used for smaller lines of 50 mm up to maximum 100 mm. In this, the disadvantages of orifice flow assembly that we were discussing in the previous slide. So here we see like its accuracy, that is the orifice flow assembly, its accuracy will be affected by the changes in the temperature, viscosity and density. So it is not a very good solution. Like if there is change in temperature, viscosity or density, definitely there will be change in the accuracy levels. The measuring range is limited by fluid viscosity, like orifice doesn't work for very high viscous fluids. Another problem of orifice flow assembly is there is pressure loss and clogging. As you know, the whole measurement is taking place through an orifice or a hole. So there is a very major chances of clogging of that. Downstream pressure recovery is very poor in case of orifice flow assembly. The chances of the plate corroding are high in case the fluid that we are measuring has got alkaline base or it is an acidic material. Then the chances are that the plate may corrode in a longer time, and then it can cause an inaccuracy. On the earlier slide we were discussing about the advantages of orifice flow assembly. On this slide we will be discussing on the disadvantages of orifice flow assembly. See, orifice assemblies have got advantages as well as disadvantages. The disadvantages of an orifice flow assembly are it requires an homogeneous fluid, it requires single phase fluid, okay, it requires the flow of axial velocity vectors. Another problem which orifice has, because of this restriction in pipeline, is it causes a pressure drop in a fluid. So areas where you require high pressure for the fluid to work in some turbine or some other machines, for that orifice flow assembly is not recommended because there is a pressure drop. As there is a huge restriction, there is a major pressure drop. See, its accuracy is affected by the density, pressure and viscosity of fluid. So for different fluids, you can have different accuracy standards. The power consumption of this meter is high because of high frictional loss in case of orifice. In case of dirty fluids, slurries and wet steam, you can't use orifice because there is a restriction, so there will be clogging inside the pipeline. So these are areas, where clogging basically happens a lot, and it can be very very dangerous to use for these lines. The process line is affected in the impulse line. In case of orifice, there is a potential of freezing and plugging, mostly in cold zone countries, as the impulse line is very very thin. So for other very fluids, it gets frozen inside the impulse line. So that is a major disadvantage of orifice assemblies.